Oh,
So the last few times in class we've been talking about the quadratic formula as another way to solve quadratic equations. And so if we remember what the quadratic formula is, just to jog our memories here, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c are the coefficients of a general quadratic equation, ax squared plus bx plus c. Last time we introduced this idea of the discriminant, which was the part of the part of the quadratic formula that was under the square root. So the discriminant, if you recall, is just going to be this b squared minus 4ac. And why we use the discriminant is to determine the nature or the types of the roots of a given quadratic equation. So if you remember last time from the chart, we had 4 potential types of solutions. And today we're going to focus on the ones that had 2 real irrational roots. And so if you remember that, we had the discriminant b squared minus 4ac was a positive number, so it's greater than 0. So it's any positive number greater than 0, but it was not a perfect square. So it was any number other than 1, 4, 9, 16, so on and so forth. So if this is the case, then we'll have this 2 real irrational roots situation. We could also have 2 complex roots. And if you remember from the video last time from the chart, this is when we had the discriminant b squared minus 4ac was less than 0. And so what that meant was we would have a negative under the square root, which would lead to a complex number. So let's go ahead and take a look at 2 examples here. So the first one tells us to find the roots to the following equations using the quadratic formula. Simplify as much as possible. So we have our quadratic formula here. So we have negative b plus or minus the square root of 4ac all over 2a. Let's go ahead and check or find our a, b, and c for this equation. So first we check, is it in standard form? And yes, it is. So we can just go ahead and read our coefficients off here. So a is going to be 2. B is also going to be 2. And C is going to be negative 5. So let's go ahead and use the discriminant to see what kind of solution we're going to have to this quadratic equation. So the discriminant is going to be b squared minus 4ac. So in this instance, we're going to have b is 2, so 2 squared minus 4 times a, and a, which we've already identified as 2.
Mindy Richardson, call extension 8000. Mindy Richardson, call extension 8000.
And then times c, which is negative 5. So if we simplify this, we'll get 2 squared is 2 times 2, which is 4, minus 4 times 2 is 8, times negative 5 is going to be negative 40. When we subtract the negative, we add a positive, so we get the discriminant is 44. So we ask ourselves, what kind of solution we're going to have? Well, 44 we know is a positive number, so 44 is greater than 0, but it's not a perfect square. So we're going to expect when we find the roots to have 2 irrational but real roots. So let's go ahead and find those roots real quick. using our quadratic formula now, we'll have x equals, so we'll have the opposite of b. B is 2, so negative 2 plus or minus the square root of, we've already found the discriminant, and that's actually, since we have it under our square root, we can just go ahead and put that number in, that 44. So we have 44 under the square root, and then that's all going to be over 2 times a, which is 2. So if we simplify this a bit further, that's negative 2 plus or minus the square root of 44 all over 2 times 2 is 4. Now, the question told us to simplify as much as possible. And here, you're probably tempted to try to cancel out a 2, because everything here is an even number, so you can just go ahead and divide everything by 2. But you can't do that here yet, because this 44 is under the square root. But we can look at this 44 here and see if we can simplify it. So let's see if we can break up this square root at all. So we know that 44 is 11 times 4, and 4 is a perfect square. So we can write this 44 as, so 4 times 11. And that's the same as saying the square root of 4 times the square root of 11. And we know the square root of 4 is 2. We can't do anything else with the square root of 11 because that's a prime number, so we just leave it. So we have 2 times the square root of 11. So we can take this 2 times square root of 11 and then substitute it into the 44 in our solution here. So we have negative 2 plus or minus 2 radical 11 over 44. Sorry, excuse me, 4. And now, since this 2 is on the outside of the square root, we can go ahead and divide it through by a 2. So we'll divide by 2, that will be 1. We'll divide by 2, that will be 1. And we'll divide by 2, that will be 2. So our answer to this is going to be negative 1 plus or minus the square root of 11 all over 2. And based on the value we found for the discriminant, this makes sense because this plus or minus is 2 real but irrational solutions. So now let's go ahead and look at another example here. We're going to do the same thing. We're going to find the roots to the following equation using the quadratic formula, and we're going to simplify as much as possible. So the first thing to notice about this is that it's not in standard form. So to get it in standard form, we're going to add 2 to both sides. So that will give us 3x squared minus 4x plus 2 equals 0. So then we'll go ahead and use our quadratic formula up there. First of all, we'll find a, b, and c. So a is going to be equal to 3. For b, it'll be equal to negative 4. And c is going to be equal to 2. So this time, let's just go ahead and plug it directly into the quadratic formula. So we get x is equal to the opposite of b. So we'll have a negative 4 plus or minus the square root. Now we'll have b squared, so negative 4 squared minus 4 times a, which is 3, times c, which is 2. All over 2 times a, so all over 2 times 3. So we'll simplify this. So negative 4 is going to end up just being positive 4. Then we'll have plus or minus the square root of negative 4 squared is negative 4 times negative 4, which is 16, minus, we'll take 4 times 3 is 12, times 2 is 24, all over 2 times 3 is 6, and then we can subtract 24 from 16, so we'll have 4 plus or minus the square root of negative 8 over 6. So, since we know that this part's the discriminant, the part under the square root, we see that it's equal to negative 8. And we know that negative 8 is less than 0, so we expect to see 2 complex solutions, or 2 complex roots for this quadratic equation. So, let's work on simplifying this square root part. So, we can rewrite negative 8 as 8 times negative 1, because that's the same thing as negative 8. So, if we do that, we can have negative 1 times 8 under the square root. We can separate them, and then we know that from our imaginary numbers section, we know that the square root of negative 1 is just equal to I times the square root of 8. But if you notice on this one, we can simplify the square root of 8 further, because 8 is divisible by 4. 8, we know, is 4 by 2. So, we can rewrite the square root of 8 as the square root of 4 times 2, which is the same as the square root of 4 times the square root of 2, and that's the same as 2 radical 2. So, coming over here, we can say that the square root of negative 8 is equal to, we'll have I times 2, so 2I times the square root of 2. And now we can take this value and substitute it in for the square root of negative 8 in our solution. So, it'll be 4 plus or minus 2I radical 2 over 6. And now we can go ahead and see if we can simplify this any further, and everything here is divisible by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. We cannot do it with the 2 under the square root. 6 divided by 2 is 3. So our solution to this one is going to be 2 plus or minus I square root of 2 over 3. And based on the value of the discriminant, which we saw above was negative 8, this makes sense. We had 2 complex solutions, and 2 solutions coming in from that plus or minus part. So simplifying is very important in these because it just makes the answers a lot nicer to work with in the future if you